Hello, my name is Enzo, and I'm one of the tutors for COMP1511. And in this video, I'm going to be implementing a linked list based program, something a little bit similar to what you have to do in assignment 2, but a lot simpler. It'll be maybe more complicated than some of the lab exercises we've given you, but easier than the assignment. And the idea of this is just to give you a little bit more revision, a little bit more practice with some of the linked list operations and linked list content you've learned so far in the course. So if you're still a bit unsure about things, you're still working on building up your confidence, this video should be quite helpful for you. Now, the program we're going to be implementing is called FIFA.c, and it's very loosely like a soccer/football player management program. We're going to work on building up linked lists of players, each of which has a name, the name of the player, and the position, which keeps track of what part of the field they play on. Classic soccer stuff. Now, /football stuff. I'm not going to get into that debate. But we can see here we have some starter code, and we're going to use this starter code, a lot of which will look quite similar to the assignment 2 starter code, but again, with some complexity taken out of it. And we're going to use this to implement some basic operations. So we'll want to add players to the list. We'll want to be able to print out all of the players in a team, basically. And then finally, what we'll do right at the end is try and convert our one-dimensional linked list of players into a two-dimensional linked list, or a linked list of linked lists. And that way we can keep track of not just one list of players, but we can keep track of multiple lists of players for multiple teams. And we'll look at what errors and issues we might run into while making that conversion. Okay, let's have a look at the starter code. So we have enum position, which is going to be the position that the player is in the team, and we're going to have a struct player. And we can see here the struct player stores an array of chars, which is our string, which is our name of the players, and the position, and then the number of goals they've scored. We might add some extra stuff in here as we go. We'll sort of find out. And then very importantly, we have this struct player star next field, which is what makes this a linked list node, because it's able to be attached to another struct player. What else do we have? We have two helper functions, and these work basically, they work exactly the same actually as the scan ID and scan type functions from assignment 2. But in this case, we're going to be scanning in the player's name, and we're going to be scanning in the player's position instead. But the way that I'll be using these in this code will be identical to the way you use the helper functions in assignment 2. And then we've got some extra functions here, which we won't look at. They're just used to implement these two. Okay, and we've got a main function, and that's it. And we can go have a quick look down here at how the scan player, scan name, and scan position functions work, but you don't really need to know. That's what it does. That's what it takes in. We'll see as we go. Awesome. So the first thing we probably want to do is decide on some of the operations we want to be able to perform on our player list, on our team of football players. And what I'm thinking is we'll do maybe an add player command. We'll do a print team command. So we print out all the players, and then we might do something like score a goal. Let's see how we go. Now, to implement these commands, we're going to need a command loop, which, let's say that the commands are going to be entered like in the following format. So maybe to add a player, we'll say A for add player, and then we'll pass in the player's position, and then we'll pass in the player's name, like so. So when we run the add player command, we're going to want to also scan in a position and then scan in a name, and then use all of that information to create a player and attach them to our player list. Now, for implementing the command loop, this is going to look very similar to the command loop in the assignment and also the command loop in the previous assignment. But basically, we want to scan in this first character by itself to tell which command we want to run. So that's going to look like scanning in a single character. So we'll say char command, and then we want to check. We want to scan in the command %c. And then we also want to make sure that that scan succeeds. So we're going to use =1 here, both to say if they press Control D, we stop the loop and we end the program, but also because we want to make sure that if they typed in, I don't know, if this failed for some other weird reason, it also ends our program gracefully. And =1 will handle both of those situations for us. There's another little minor detail here, which is really easy to forget, but we want a space before the %c. Otherwise, we might scan in some new lines and spaces and non-letter characters there, which will be a little bit difficult to debug. And then we might want to also print out some sort of nice prompt. Let's do printf enter command. Awesome. Okay, and then if the command is a, command equals a, we're going to run the add player command. Now, just to sort of like test as we go, let's print out and make sure this code works so far. So we'll say, if it's this, we say player command, new line. Otherwise, let's print out invalid. Something like that. And we can run the code so far. DCC FIFA.c-o FIFA. So it looks good so far. We've compiled. And if we run this, we get the prompt enter command. And if we type in A, we run the play command. Beautiful. And then if we type in something else, we get invalid command. Nice. So it looks like our command loop code is working so far. And so instead of this, we can fill in the code we need to add a player to our list of players. There's a few things we need first, though. We actually need some sort of variable here to keep track of our list of players. And the way we do that with linked lists is we keep the head pointer to the list. So we'll make a struct player star head pointer. And I'm not going to call this head. I'm going to call this player list. And we can just keep track. This is our list head pointer. And we usually like to start our variables off initialized to something. In this case, null is quite nice. Null tells us that this list is empty, that there's nothing in our linked list. Awesome. And in this code, we're going to want to implement our add player. Now, let's see. How do we want to do this? We have this diagram here, which shows us a little bit how our linked list is going to look once we've got lots of players in it. To begin with, though, it's just going to start out like this as null. And we want to add a single player in. Let me steal one player from here. We want to add a single player into this list. Now, I'm going to say that our add player command is going to add the players to the end of the list. So each time we create a new one of these, it's going to put it after any existing ones in the list. And so we're going to have to turn this into, oops, this. Okay. Now, before we figure out how to do that, let's just work on scanning in what we need for this command. Now, we could do this here. We could do scan the position and then scan the name here. But just to sort of break things up, to keep things nicely separated, I'm going to create a add player function. Now, not quite sure what this will return yet, so let's just set this to void. What will this have to take in? Well, right now we're saying we'll scan in the arguments we need inside this function. So the only thing we'll need to take in is the player list, so that we can actually like modify the linked list and add players into it. So let's pass in this. And that should be it. Okay. Now, let's have a think. We will scan in. What did we say? We said this is going to be the format that our add command is in. So we've already scanned in this A here for the command letter. So we should be looking at just scanning in the position and then the name. So to scan in the position, we're going to use the scan position function. And if we look at this, it says that it returns us the position that was entered. So, and it takes in nothing. There's void there. So we should be able to call this by just saying scan position. Oops, not scanf. Scan position. Empty brackets. And then it should return us the scanned position. So let's say enum position equals. So we're creating a variable called position, which is of type enum position, and when we scan in the position, that'll get returned into this variable. And then we also want to scan in the name. So to scan in the name, we use this function here, and this doesn't return anything. Instead, because you can't return arrays very easily in C, it takes in your array, sort of like an empty array of chars, and then it fills in the letters and places a null terminator at the end for us. So we should be able to say char name, create an array of chars of size max name length, and then call the scan name function and pass in our array. And then this function will go and modify our array. And once it's done down here, name should now be filled. Awesome. And then at this point, I'm actually going to make another function again so that we can implement our actual linked list insertion separately from our scanning code. It's not super important, but it can be a nice way of breaking things up, especially if there's a lot of like scanning and parsing you've got to do here, and then the logic to actually insert something is also quite long. So let's do that here. I'm going to create a new function then, and let's call that add player to end. And this is going to take in the player list, but it's also going to take in our enum position. And let's just make this a little bit nicer. It's going to take in our player position, and it's going to take in our char name max name length. Awesome. Let's implement this function as well. I'll write this down here. And again, we'll figure out what this returns later. And we know that in this code here, we want to call our add player to end function and pass in everything it needs. So it needs the player list, it needs the position, and it needs the name. Okay, and then we can really start working on this code here. So this is going to be a tail insertion, because I said we were adding to the end, which means it's also going to be basically the same code you've seen in the lectures, which is nice. So if, as I write this, if there's some details that I brush over, maybe go have a look back at the, what is it? We've got the week 7 lectures and week 7 lecture code. And you'll see in here we have, add node to end of list. That is probably going to be very similar to the code we write here. But let's do it again manually, just for like a little bit of practice, a little bit of revision. if we want to add a player to the end of the list, and we have a linked list here, whoops, let's undo my changes here. Oh. There we go. Back we go to this one. We need to add a new player at the end here, which means ultimately what we want is we want this arrow to go down here, and then we want this last thing to have next pointing to null there. And that way we've got a new player at the end, and the previous player, what used to be at the end of the list, its next pointer now goes to our new player, and then the new player is directly before null. So it's the last thing in the list. Now to do that, we need to change this arrow here, the next pointer of the last node in our list. Okay, let's work on that. Let's work on finding this last node here and then changing its next pointer. So to find the last node in the list, we can use a while loop. We can say struct, let's create a temporary pointer so that we can loop through the list. Struct player star current, and let's start looping from the head of the list. So start the current pointer at the start, and then we're going to loop through. And our aim here is to find the last node. So we want, at this point, current is pointing to the tail of the list. Awesome. So if we have our current pointer, let's say this is our current pointer, we want it to move forward, forward, and then stop here. And we can see this is one spot before null. So that tells us that we want to loop until current next hits null. So basically keep looping while current next is not equal to null, and then when we hit a point where it is equal to null, we must have hit the last item in the list, so we stop looping. And here we just need to do current equals current next to move through the list. Okay, and at this point, we should have current be pointing to the tail of the list. So we should, to do our insertion, just be able to say current next equals our new node. New node. And we also want to make sure that like new node next points to null. Now, how do we actually create a new node? To create one of these structs here, we need to use malloc. And we could write all the code to do that here. We could write like, okay, let's do, what would it be? It'd be struct player star new equals malloc. So malloc gives us a certain amount of allocated memory, and we have to tell it how many bytes of memory we want. So we say size of, and we want enough space for a struct player. So we say size of struct player here. And that creates that memory for us, returns as a pointer, which we store in new. And then we should probably initialize all the fields of new. So let's just say all players start with 0 goals scored, and we can like modify that later if we want. So that'll start at 0. The new player's name is just going to be the same as the name we pass in. And then the new player's position should just be whatever position was passed in. And then also the new player's next pointer. Good to always just start pointers as null. And in this case, we're putting this node at the end of the list, so next should be null anyway. Okay, this is almost correct. This line is a little bit of a problem. Name here is a string, and player arrow name, the name field inside our struct player here, is also an array. It's also a string, an array of chars. And you can't just set one array equal to another array. We actually have to loop through and copy every character over one by one. Luckily for us though, there are some built-in functions that help us with this. The main one here is going to be string copy. That's it there. And we can see here, actually, does it tell me? Ah, beautiful, it tells me. It takes in the destination first and then the source. So we put the thing we want to copy into first, and then we want to put the thing that we want to copy from second. And that should do the work of looping through the arrays and copying everything over for us. Awesome. And then that's our code to create a new struct player, a new linked list node. Now, this stuff is kind of okay to have like this, but if we later on change what's inside our struct, we might have to change this code. If we're creating nodes in multiple places, we might have to change it in multiple places throughout our code. So really, something like this is much nicer in a separate function, in some kind of helper function. In this case, I'm going to call that helper function create player. And we're just going to copy in everything we had there. And then this code here is going to take in the name and the position, and it'll just set goal scored to 0 because we're just starting everyone out as 0, so it doesn't need to take that in. So it needs enum, position, and char name, max name, length. Cool. And let's just do this again as well. Okay. And then we want to create, malloc our new node, set all its fields, and then also we need to return the new node. Okay. Just to keep our code nice, let's also add this as a prototype to the top here. And then we should be able to call this function down here, where we used to make it manually, but now we can just say create player. And what did we say? Create player, was it in position first, I think? And then, yes, and then it was name next. So position, then name. And then, what did we say? We said we wanted the thing after the tail to be our new node. So we should just be able to insert this here. So we're creating a new player and putting it after the tail of our list. Okay. Have we forgotten anything? Yes, we have. All right. But let's run this code and find out. Let's go DCC FIFA. Oh, okay. Use of undeclared identifier position. Oh, I think I've accidentally messed this up somehow. Okay, what was this supposed to be? This was supposed to be struct player star player list. That looks right. Then we have struct position. Oh, we have enum position. We have our name. Was that our problem? Okay, no. I've typed some other error here. Let's have a look. Let's scroll up to the first issue here and say use of position. Okay. So it's saying here I've said struct position here, where I probably meant to type struct player, because we don't have any struct positions here. And then we solve the first issue, and let's just check our code. Okay, something else is wrong here. We also have... and we also, whenever you change a function, you also have to change its prototype, of course. Struct player star. And then we're getting closer here. What does it say here? Unused variable player list. I mean, this makes sense. It's saying here in main, we have created this player list and we never used it. Now, that's because we never actually called the new function we made. So we want to call add player here and pass in our player list. And then that's going to scan everything in and call our other function. Let's do that here. Add player and pass in our player list. Awesome. And now let's try run. Okay, that looks a lot better. We can now run our code. We should now be able to say add player. And we said add, and then we scan in a position. So we should be able to say striker, and then name, let's say Enzo. Ooh, and we get a null pointer error. You are using a pointer which is null. A common error is using p field when p is null. And we can see that's exactly what's going wrong here. So this is the error that I actually was thinking was going to show up, which is that we've said, oh yeah, let's just check if current next is not equal to null. But we never made sure that current wasn't null. And if current is null, then we're dereferencing null and trying to access a field inside it. And that just breaks everything. You can't do that. So when exactly does this issue happen? It happens in the situation where our list is empty. Oh, this is looking a bit nasty. Ignore all the random arrows. When our list is empty and we want to insert our new player, there's actually no struct player next here. Yep. So we have to handle this situation, this edge case, separately. So if our player list equals null, if our list is empty, we want to handle this separately. And we can figure out, okay, if our list is empty and we want to add a player to the end, that's the same as adding a player to the start of the list. So we want to change where the head of the list is to point to our new thing, and then make sure this is pointing to null, and that looks correct. So inside here, we want to say player list equals our new node, which we can create using this. And then in this case, we're sort of done here. So we'll say, otherwise, do everything else. Instead of doing if, edge case, else, do the general case of inserting at the end here, a nice way of structuring this can also be to use early returns, which is what I'm going to go for instead, which is we return here to say, if this condition occurred, we exit our program early. Sorry, not the program, exit this function early, which means no more of this code runs. Sort of implicitly wraps everything else in an else statement, because none of this will run if the if statement ran. So now we're saying, create the player, set the head to the new player, and then return. Otherwise, if the list wasn't empty, we find the tail of the list and then add after that. Okay, and now will our code work? Position and then name, I said, Enzo. Okay, so it seems to have worked. And if we run this again, it's also going to seem like it worked. But, oops. Oh, I can't paste here, apparently. A striker Enzo. A striker Enzo. Yeah, so it looks like it's working. We don't really have any clear indication yet here because we can't print out a list. I'm going to give away that this code does not work. And if you've been paying attention to the lectures and you're feeling a bit comfortable with that code, you'll see exactly why. And it's because we're returning void here. When we pass our player list into a function, this pointer here is actually copied. Let's go back to some diagrams that don't look awful. Here we go. So inside the function, we don't actually use this original pointer. Let's say this is the one from main. We pass it into a function, and this pointer gets copied. We get a copy of our head pointer, which also points to the same place, but it's a different variable, and that's really important. And this is our one in add player to end. So if we change where this pointer goes, we haven't actually affected our main function. Our main function still thinks the head of the list is here, even if we move it to point somewhere else. And that's exactly what we're doing in this case. In this case here, we're saying, oh, the list was empty, so let's change the head of the list from pointing to null to pointing at our new node. Now, the easiest way to fix this is just to make our functions return the head of the list, returns the new head of the list. So if this function changes the list, it returns where the head should be now. So in this case, we'd say instead of void here, this should return a struct player star. And down here, instead of return, we say, okay, return whatever the head of the list is. And in this case, the head of the list is player list here. But as we found out, changing this variable here doesn't actually change anything inside like our main code. It's only changing the copy of the pointer we have in our function. So we could also just return this here. Return the new node and saying, oh, this new node we created, this is now the head of the list. And down here, we also need to return something. So at this point, we'll say we haven't actually changed the head of the list if we added to the end, so the head of the list should be the same. So we can return player list. Whatever used to be at the start of the list should still be at the start of the list. We also have to change our add player function because this one returns void right now, but really this should also tell main if it updated the head. So we also need to say struct player star here. And then whatever this returned as the updated head of the list, we should also pass that forward. Say, okay, if this changed the head of the list, let's also say that's the head of the list by returning it from this function. And then finally in main, when we call this function, it returns the updated head, which we need to save somewhere. If we just call it like this, that new head of the list is just discarded and we sort of lose it. But if we save it back into our player list, then if the player lists stay the same, it's sort of just saving the player list back into itself so it doesn't modify it. But if we did actually change the head of the list here, then importantly, it will modify this variable here and change the head pointer from being null to being our new node. Okay, let's check that this works. Or check that it compiles. Again, it's really hard to see if linked list code works before you print stuff out, so we'll be implementing that next. But if we do a striker enzo, it seems to work. We don't get any crashes at least. Let's print things out just so we can tell what's going on. Okay, printing a list, that should be pretty easy. Let's create a new function for it as well. Let's do, again, I'm just gonna make it void until we figure out if it needs anything else. Print players. And let's say this takes in the head of our list as well so that it can loop through and print everything out. And then we're going to call that down here. So we'll say else if command equals p. We're going to call this function. So print players. Pass in the player list. Okay, and then we better actually go and implement this function somewhere. Okay, so we've taken the player list. Let's just loop through and like print out the name and the position. Now, we've probably taught you to always create a temporary pointer so you don't lose the head of your list. And that is a good idea even here. It is not strictly necessary. We could just change player lists because as we said, this is a copy of our original head pointer. But don't worry too much about that. That's not super important. We can say current. Now we want to loop through the whole list and then perform an action on each element in the list. So we're probably going to want to loop until we hit null. This way, inside the loop here, we're going to pass through every single node. Whereas in this other loop we wrote up here, this one doesn't pass through everyone. It passes through all of them and then stops on the last one. We also want to print out the last one. And so in here, we can write our print code. Now, what I'm thinking is we'll just do something very simple here. We'll say like printf. Let's do %s to print out the name. And then we'll print out the position. Okay, so printing the position will be a little bit tricky because it's an enum, but we can just write some quick code for that. All right, okay, so I've written up some code just to print out a player struct, and that's this function down here. And this is often something we'll just give you because we don't want you to worry about like outputting something like this in like an exact format, and that's the case in the assignment. We've given you a print carriage function. In this case, all we're going to do is we're going to print out the enum position as a single char, and then print out the player by itself. And then I've finished writing the print players function up here. We call print one player, and then just to make things look nice, I'm going to print out an arrow and then print out an X at the end, and sort of just have all the players on one line. And of course, when we add new functions like this down here, we also need to add them at the start here, print player. Okay, let's test this code. Okay, that looks good. Then we go FIFA. So we should now be able to say print player. So if we do P, print out an X, because there's no players in our list. If we do add position striker Enzo, and then we do print, we have Enzo, position striker, and then nothing. Let's do add Sasha as the goalkeeper. Oh, it's this first goal, and then Sasha, print. We get Enzo, and then Sasha, and then X. Looks good. Looks like our print code is working, and our add player to end code is also working. Let's move on then. Okay, so a few more things here. We might find out later that there's extra conditions we want to sort of handle with some of these operations. Print is pretty straightforward, though we might want to add something to like print it differently if the list is empty, something like that. Not going to worry about that for this program. But we do have the issue of if we add a new player, add a player, and we don't give it a valid position, we do something like this. That's probably a bit long. Something like this, that's not a valid football position. And then Enzo, it sort of just adds it anyway. If we print it, we'll see it thinks we're a midfielder. And that's just because I didn't check if it was invalid down here. I just said if it's not one of these ones, it must be a midfielder. We can see we also have invalid up the top here. So we could handle this in print and print out something different when it's invalid, but it would be nicer if we could just prevent the player from being added at all when the position is not one of the valid positions. Now, to do that, we basically want to get some code and prevent it from running. And that code is here. In this function here, add player, which right now just scans things in, we can also make this handle our error conditions. And the code that we don't want to run is this thing here, right? If this position here is invalid, we don't want this line of code to run. That way, no player is added, our list is just like left untouched. And if we want to sort of conditionally decide whether something should be run or not, that sounds like an if statement. So if some condition here, we can figure out what that is, and then we want to run something else, we maybe want to do something else. I'm going to say, let's have this be handle invalid position, and this be everything was correct. So if everything was correct, then we do actually want to run this code here. So we probably want to say player list equals run our code, save any updates to the list, and then at the end here we can just return the player list. And then if position was invalid, let's print out some error message. Printf invalid position. And then all we need to add is, how do we know if it's invalid? Well, if we look at the scan position function, it returns invalid if the position that it scanned in wasn't valid. So we should just be able to say if position here equals invalid, print out our error message, otherwise run our insert code. Okay, and one of the nice things about separating our code out and doing this here is we actually never even create a new player if it was invalid. We check all of this before we even try to do our insertion code. And if you've gotten up to some of the later stages in the assignment where you need to like make sure you free everything you malloc, making sure you never malloc something until you actually know it's going to go into the linked list is one really good way of like preventing memory leaks that you don't find till much later. Okay, let's check this code again. So if we, let me clear this. Okay. And let's try adding a valid player to the list. So add striker Enzo. Print it out. That looks good. And then if we do add Asdif Sasha invalid position. If we print out our list, we can see nothing was changed. So that looks good. Okay. Let's now have a look at, we've got a working program here. We could add some extra operations, but in the interest of time, let's try and take our existing code and convert it into something that can be used to store multiple lists of players. Now to do that, the first step is to go from something that looks like a less horrible version of this. Let me just undo some of these changes. Something that goes from this to this. We need to wrap our existing list in a new struct. So if we look at this, we have a new struct here called struct team, and that contains the head pointer to our linked list of players. And by doing this, we can then attach multiple of these struct teams together. There's actually other benefits for putting your team, your linked list head pointer in another struct. But in this case, the main one is just that we can link multiple lists together. So now the process of doing this is potentially going to break old codes. We're going to be a bit careful as we go. We're just going to rerun things to make sure everything still works once we've changed things. But it's hopefully not going to be too difficult. The first thing we need to do is we need to actually create this new struct here, a struct team. And I've said here that the struct team is going to contain struct team. It's going to contain a team name, so char team name, and let's also give this max name length. And it's also going to contain a pointer to the head of a list of players. So we'll have struct player star pointer to some list of players. I'll just call that players. And then we also need a next pointer, so we can attach it to more struct teams. And in this case, I'm going to call that next team. Awesome. So we have our struct team, and we're probably going to want to create one of these immediately. So we're just always going to keep our linked list inside one of these structs. And then if we want to create more teams, we'll create more of these structs. We'll malloc more of them. If we're mallocing things multiple times, we probably also want some sort of code here that initializes and mallocs a struct team for us, similar to our create player. So let's do that. Let's do struct team star create team. Okay, and this is going to take in whatever information we need for a team. Now I'm thinking, let's pass in the team's name and let's save that in. And let's just set these other two to null. So teams always start out empty when we make them. So we're just going to pass in char name, and this is going to be of max name length. And then inside here, we need to malloc a struct team. So struct team star new team. And then we're going to malloc enough space for a struct team instead this time. And then we're going to initialize all the fields here so we don't run into trouble later on. So we'll say new team. Next team is going to be null. And new team players. It's going to contain no players to begin with, so that's null. And then just like for our player, we need to stir copy the name into our struct. So that will be stir copy into new team name, or team name from name, like so. And then we're going to want to return this new team. Okay, let's do this properly. So instead of having this above our main function, we'll have a prototype here, and we're going to copy this to the bottom here as well. So now we have this function, which we should be able to use just here to create an empty team. So let's do that. Let's do struct team star team list. Actually, let's call this teams, plural, so multiple teams, is equal to a new empty team. And let's just call this first team UNSW. That makes sense. So we're creating an empty team called UNSW, mallocing it, initializing it, and then saving a pointer to it inside this teams variable here. And then this contains a player's pointer, and that's what we want to use for all of our add player, print players, all of these functions here that take in a pointer to a linked list of players. Instead of just using a struct player by itself, we actually want to use our pointer that's inside this struct here. Now, the easiest way of doing that is just on each of these lines where we said player list, we can just delete player list and replace player list everywhere with the pointer that's inside our teams struct, which is teams arrow players. So we're going to pass in players here, and then this is going to return the new head of the list if it changes it. So we need to save it back into team arrow players. And if we want to print out the players inside this team, we're going to say team arrow players here as well. Now, I mentioned that there are some other benefits for putting things inside a wrapping struct, right? Having our linked list head pointer be stored in another struct. And we can actually take advantage of that here. And I'm just going to show this quickly. But we went through all the pain of, like, we had to change this function and return the new head of the list because we can't save it inside the function. But if instead we have this wrapping struct, and this contains our head pointer, then when we pass, if we were to pass this into a function instead, then modifying the head pointer inside this struct does actually change where the head of the list is, right? If we pass this into a function instead, well, inside that function we'll get a copy of the pointer, copy of the pointer to this wrapping struct. But then when we change the head of our linked list of players, we're changing this pointer here. There's only one of these pointers. So the advantage of this is we wouldn't have to return the new head of the list every time we update it. We could return something else, something more valuable. Maybe we could return like the number of players in the list, or we could use this position for something else. I'm going to have a go at showing what that looks like, but be aware this is not something you would have to do, and it's not something you'd necessarily have to do for the assignment either, but it is another benefit, and it's something you can take advantage of in some of your functions if you choose. So to do this though, we'd need to change our add player function here. So instead of taking in a player list, it's going to take in a struct team star team. And we said it doesn't actually need to return anything. So this will just be void add player team star team. And let's go ahead and change that here as well. Okay. And then we're also going to need to change it here for our add player to end function. So again, instead of this function here taking in a struct player, it's now going to take in a struct. Oh, it's going to return nothing because again, this also doesn't need to return anything now. And it's going to take in a struct team star team. We're just going to have to modify our code a little bit down here to make sure this all works. Now, we no longer have our struct player star player list. We no longer just have a raw pointer which stores the head of our list. This is gone. We now have the team struct, and inside the team struct, we have the players pointer, which is the head of our list. So everywhere we used to use this player list here, we want to use this new pointer instead. So here we go. If player list equals null, well, player list doesn't exist. How do we check the head of our list of players? That's team arrow players. And in this case, instead of returning the new head of the list, we do actually just want to save that into this pointer. So set the pointer to point to our new struct, our new player, so that the head of the list will be this one new player. Okay, and we'll keep going. Down here, when we say current starts at the head of the list, well, our head of the list is actually team arrow players. And then down here, we no longer return the new list as well. So we can see that this code is a little bit... Oh, we also still need to return early here to make sure no more code runs. But this code is a little bit shorter, a little bit simpler. It's not a huge deal here though, but in other places, passing in the struct team instead of the struct player pointer could make things a lot easier if you had some other information you wanted to return. Okay, we also need to change this over here because this function no longer returns anything, so we should delete that. And instead of saving the result of this back into the head of the list, this should just modify the list itself. Sort of bypasses all those issues we dealt with earlier. And let's have a look at this here. Does this work? No. Okay, I've made some mistakes. We need to modify... Oh, I think I might have messed something up here. Add player to end, struct star team. Nope, that looks good. Let's have a read of these errors. It says expected semicolon after struct. Of course. When you write a structed Z and you forget the semicolon at the end, everything breaks. So that is definitely part of our issue here. And then we also have another issue here, which is that now we've modified this to no longer take in a head pointer to our list. It just takes in the team struct, a pointer to the team struct, and doesn't return anything. Let's try this again now. And we're missing another semicolon here. Team arrow players. This is on line 147. Where have I done that? 147. Oh, I need to comment that out. That was just my example code to show where the head pointer was. And we have, yes. Also here, we're no longer passing in the player list here, because that doesn't exist. We just pass in the struct team. Okay. Does this code work after all those changes? Add a player who is a goalkeeper, whose name is Enzo. Print that out, and it looks good. Looks like it worked. Let's do another one just to be safe. Add a defender, Ben, maybe. Print. We've got Enzo and then Ben. Awesome. Okay, so it looks like this is working now. We're instead passing in our team here. But we can see that, like, if we wanted to do something like print players, you can just leave your functions the way they were. You don't need to pass in the struct team instead of just the player head pointer. Either is fine. Okay, we're not quite done here though. We have managed to do this. We now have our linked list inside a new struct. So we have a new struct that stores the head of our list of players, but we ultimately want it to look like this. We need a way of adding multiple lists of players. In other words, right here, where we have our next team pointer, we want to be able to change that and add a new team here. And then we're probably going to want a way of like changing which team we're looking at the moment. We'll figure out how to do that last. Let's just say, like how we added players to the end of here, let's just add players to the end of our struct team. So it should basically be the same code we had as before. Oh, actually, no, to make it even easier, let's do a head insertion on our list of teams. So we're going to add a new struct team. We're going to add a new command which adds a struct team to the start of this list here. Which means we're effectively going to create a new one of these. And then we'll change this pointer to go up to the top. And then we'll change the next pointer here to go here instead. And then we have a new struct team with sort of no players. Like so. Okay, let's write that code. Let's call this command else if command equals T for team. So the command is T, and let's plan out what this command will look like. So we're going to pass in the T letter, and then we'll say pass in the name of the team as well. So some name here. And just like the other ones, let's make a function for this. So we'll do struct T, struct team star new, what do we say? Add team, and we'll take in our struct team. So this is just another linked list insertion. So we'll return the updated head of the list, and we'll take in the current head of the list. And I'm going to write this down here. Oh, no, I'll write this at the top, just because it's what we're currently working on. Here we go. So we can say add team to perform a head insertion. Let's see what we did. We said we create a new team here. Let's do that first. So we'll say struct star team new equals, struct team star new equals create team. Pass in some name here. And actually, what did we say? We said, oh, those are the wrong brackets, I see. We're going to scan in the name from the user. So we'll do our scan name function, which again, we have to create our name array first, and then pass that into the scan name function. And then we can pass this name into some other code here. So we'll do name there, create a new team with a new name, and then we want to make this new team have its next pointer go to what used to be at the head of the list. So that's new arrow next equals head. Now, next doesn't work here. Next is not some magic word that like gives you the next pointer on the linked list. This is just a field inside our struct. So for our struct players, that was struct player star next. But in this case, it's struct team star next team. So whatever name this is here, that's the name we've got to use to modify how our linked list is linked together. In this case, instead of typing, where is it? Instead of typing new arrow next, we should be saying new arrow next team, because this is our next pointer for our linked list of teams. So we create a new team, we set the head to be after our new team, and then we want to return whatever the current head of the linked list is. And in this case, we want the head of the linked list to be new. Awesome. And then down here, we'll say if command equals T, we'll do teams equals add team teams. Okay. Now, you might be looking at this and saying, we could really, split this in half as well. And I'd say you're right. You could have one function here for scanning and one function here for doing the head insertion. In this case, because we're not going to bother with any error conditions and both of these are so simple, I'm just going to leave them all together. But you would be right if you also wanted to split it up, and especially if you had any extra sort of conditions or errors you needed to handle, or any extra complexity to inserting it there. Okay, let's have a look at if we can get this code to compile and work. So amazing, it actually compiled first time for once. Okay, let's run it, and let's say, okay, we can add some players to this team. So we start off with the team UNSW, and let's add a defender, Tammy this time. Print, we've got Tammy, defender, and then no one. And then if we do the T command, we should create a new team and put it at the start of our linked list of teams. Ooh. It looked like that didn't work. Looks like we've sort of gotten stuck here. Let's see, if I type other stuff here. Oh no, I need to type in a name, of course. I needed to type in a name for a new team. So if you do T, you also need to type in like, what's another team? The Australian team, AUS, sure. And if we do print now, we see we have no players. Because right now we've just sort of said, we'll do all of our commands on whatever team is at the start of our linked list of teams, because we're always just passing in the head pointer. And so when we try and print the players or add players, we're just sort of adding them to this team at the start. But that sort of makes sense. We created a new team. We put it at the start here. And we called this team AUS. And then this pointer goes here instead. And this pointer goes here. And then this is just empty for now. But we can run our commands now to add stuff here. Now, we probably don't want to only be able to manipulate this first team. That's not very useful. So we probably want some sort of extra command here to change which team we're running commands on. And I'm going to make just an next command. So we'll do else if command equals n. We want to switch from modifying the first team in the list. So instead of modifying this team, we want to switch to modifying this team down here. Now, we can't do that by changing this pointer here. This is our team's pointer. If we modify this, we do lose whatever was at the start of our list. You know, if we keep running next and we keep trying to move this around, we're just going to keep losing teams. So we probably want another pointer here, or another way of keeping track of which team we're currently modifying. A pointer is going to be easiest here. It's not the only solution. You could also like add something into here, like an int currently selected or something into your struct team. But I'm going to go with a pointer because I think that's going to be easiest. But effectively, we need another pointer here, which keeps track of what team we're looking at. And it's like our cursor. So I'm going to call it struct team star cursor. But you could also call it like current team or selected team or something like that. So struct team star cursor, and we're always going to start off by looking at the head of our list. And then effectively, if we run the next command, we want to move the cursor from being at the start of the list to being the next thing in the list. So we'll have another one of these. This will be called, oh, let's move our head pointer back to where it belongs, back up here. And we have our cursor. And if we type the next command, it's going to move from this one to this one. And then if we type it again, it should move from this one to this one. That should be pretty easy to implement. Let's make a function for this. Functions are great. If we keep everything as a single function, this command loop should be super short. Let's do that as well. Let's do struct team star move cursor. And we're going to take in the current cursor. Struct star cursor. Struct team star cursor. And I'm also going to take in the head pointer to our list of teams, just in case we want to use it. Now, move cursor, there we go, and I'm going to implement this down the bottom as well, so we'll put a semicolon there. And then let's say, all right, so how do we move the cursor along? Well, if the cursor is sitting here, and we want to move it to here, that's sort of just like doing one iteration of a loop. So we just need to basically do cursor equals cursor arrow next, and then return the cursor. And that should be it. There is one slight issue here, which is what do we want to do when the cursor hits null, when we go past the end of the list? And look, there's a few different ways you could handle this, but just to sort of make things simple, I'm going to say if we get to the end of the list here and we hit the last one, let's just jump to the top here and instead print out, instead go back to the, ooh, that's a bad arrow, go back to the head of the list up here. So we're going to wrap around, and that way we can keep like cycling through all our teams. So we say cursor equals cursor next, if cursor equals the end of the list, which should be null. Oh, also, this shouldn't be next. We should say next team, because that's what the field is called. So if cursor, move cursor to the next thing. If the next thing is empty, let's just reset the cursor back to the head of the list. So we'll say cursor equals the head of the list, and then return the cursor. Okay. And then when we call this, we'll say cursor equals move cursor, cursor. Okay. And let's see if this code works. So we should now be able to say, oh, let's just clear this screen first. And we'll do DCC FIFA. Oh, okay. Too few arguments to function call. Because we pass in the cursor and we pass in the head of our list. So that should be teams. That looks better. So let's print out our list. It's an empty list. Let's go add midfielder named Enzo, add a goalkeeper named Ben, add a striker named Sasha. Okay, and then print. And we've got our linked list. We've added all our people in. And then we should be able to say add a new team, which is just T and then the name of the new team. So let's call this like the Australian team. And so in the Australian team, if we print out now, we should still be... interesting. Okay. So we changed the team here. And it looks like our cursor is now pointing to an empty team. So we might have a mistake here. Or maybe this is right. We'll find out. Let's see. So we've created a new team here called Australia. Let's see. If we move the cursor, if we say next team, do we go back to our old team here? No, we don't. Okay. Which means I've made a mistake here somewhere. Let's have a quick look. Okay, so I figured out what's wrong. We forgot, and by we I mean I, forgot to update what we were passing into our other commands here. So let's do that instead. Let's pass in our cursor and our cursor teams. So we're not always looking at the start of our list. We're looking at whatever team we're currently on. Okay, and let's rerun this. There we go. Add Ben. I'll add a striker named Ben. Let's add a defender. Defender. Oh, I can't spell right now. Defender Enzo. Let's print that out. We have a linked list with 2 people in it. If we append, if we add a new team to the start of our list, and we call that team AUS, and then we print. Yep, we're still on our old list. But if we then say next, so we move to the next team in our list, and in this case we're going to sort of wrap around and go back to the start, and now we print, we'll see we've got an empty list here. And then we can add people to this team instead. So we could add striker, or let's say, yeah, striker, Sasha, to this team and add midfielder field Tammy to this team as well. Print. And we've got, in this team, we've got Sasha and Tammy. And in this, if we move on to the next team, we've got Ben and Enzo. Next. Back to the first team. Next. The second team. Awesome. All right, that pretty much does it. I'm going to add one more command here, just very quickly, just so we can sort of see the two-dimensional linked list. So we're going to add a like print all teams command. Yeah, okay, let's see how that looks. Okay. So we should now be able to say print the current team and also print out all of the teams. In this case, we have UNSW, and then UNSW is empty, but we should be able to say, let's add a player to here, striker Ben, and then let's print that out, and then let's create a new team called AUS. Let's move to that team. So we're, it's capital N, isn't it? Yep, so now we're looking at the AUS team, and we should be able to say add a striker Tammy to this other team. Okay, and then if we print out the entire list, we can see we've got the AUS team with Tammy in it, and we've got UNSW with Ben. And we can probably add more of these even. We can just do like add defender, I don't know, Bob. And then let's add a new team even called other. And then let's move to that team. So now we're looking at the other team, and we can add more players here. We can add a goalkeeper named Bill, add a defender named Enzo, and then we print out. Yep, and if we print out the entire list, there we go. We can see we've got this linked list going down of teams, and then inside each of these teams, we've got a list of players. That's our two-dimensional linked list. That looks kind of like the diagram we've got over here. Awesome. Okay, I think we'll call it there. There's probably some more commands and things I could add here, but we've covered a lot of the important things, like some 1D linked list operations and some 2D linked list operations. So if you're stuck on any of the related stages in assignment 2, hopefully this video has been of some use to you. And if not, hopefully it's just been good revision for like linked list concepts and operations before the final exam. I should say this code is not perfect style. I've not done a header comment. My functions down here should all have comments above them, and they do not. If you're writing code, you should definitely implement that documentation here. And also, these commands here should probably be hash defined. That way, proves readability here. It's obvious that instead of A here, or a better example is N here, is that like move cursor? Is that next thing, or is that like new? So next team, or is that new team? So it would make a lot more sense if this was command equals command next team, or something like that. That would make our code a lot more readable, and it also means someone can change this hash define if they want to modify the controls of our game. But I'm not going to bother here. So yeah, I think that's the end of this video. Good luck for assignment 2 and for the rest of the course, for the final few weeks of the course. I hope you've enjoyed it so far.